All right, we just did this exact same problem with the box method and the pictures, but I want you to look at how the place value box and the standard algorithm that your parents want you to do, they're the same thing, they just look a little bit different, okay? So in both of them, I have 6,000s, 300s, 4 10s, 8 1s. I'm dividing by 2. The same thing over here. 6,000s, 300s, 4 10s, 8 1s, divided by 2. Okay? So, in my box method, I did write my multiples here down the middle so that those are already done for me. If I didn't know my 2's, it would be more important whenever we're like dividing by 7s or 8s or those ones that we're not quite as familiar with. But just to practice, I did put my multiples of 2 down the middle. I have 6. 6 divided by 2 is how many? How many will be in each group? 3. Okay? If I put 3 in each of those 2 groups, how many did I use? 6. Because it would be like 3 times 2 equals 6. So how many are left over?
0.
All right. Now, I'm going to pause at that point. Okay? I'm going to pause. Right. Actually, I'm going to go to the next step, and I'm going to go ahead and bring over that 0,000s that I didn't have to break anything up to put it in my hundreds place. Okay? Now, I'm going to jump over to my standard algorithm that looks a little bit different, but it's the same thing. Okay? If I have 6,000s and I need to divide them into 2 groups, how many thousands does each one get? 3. So guess what? The 3 goes on top again. If there's if I put 3 in each of those 2 groups, how many did I use? 6. So how many are left over? 0. Now, instead of bringing my 0,000s over to my 300s that I already had, this is where it looks different. I'm just bringing it down. Instead of bringing my 1,000 to my 100, I bring my 100 to my 0,000s. Okay? So now I have 3. It's the same 3 that I see here. Okay? It's the same 3. It's still 0, 3. So coming back over and looking at my place value box, because I'm a little bit more familiar with this, if I have 3 divided by 2, how many does each one get? 1. If I have 1 in each of those groups, how many did I use? 2. So how many left over do I have? 1. And then what do I need to do with this 100? Bring it over, and I'm breaking it into those 10. I'm breaking it into those 10 tens. Same thing here. If I have 3, how many can I put in each of those 2 groups? I can put 1 in each group. If I have 1 in each of those groups, how many did I use? 2. So how many do I have left over? 1. And again, instead of bringing my 1 over to my 4, I bring my 4 down. I still have 14 tens. It's still 14. Still the same thing. It's just written a little bit differently. It's just recorded a little bit differently. Right? It just looks different. But it's really not. So if I have 14 tens, and I need to put them in those 2 groups, what do I need to, how many does each group get? 7. Remember, if I'm not sure, I can put my finger on the first multiple of 2 that's bigger than that 14. Count how many are above it. 1, 2, 3, 4, 5, 6, 7. If I put 7 in each of those 2 groups, how many did I use? 14. So how many do I have left? 0. So I'm going to bring that 0 tens over to my ones place. So how many ones do I have now? 8. So I'm going to step back over to my long division with the standard algorithm. If I have 14 divided by 2, how many does each group get? How many? 7. 7 times 2 is? 14. So how many are left? 0. And then again. Ooh, that was a long one. That was a long arrow.
Why is that one longer than the other arrow?
They just have to go down further. So I have 8 ones in both my place value box and my standard algorithm. So 8 divided by 2 is? 4. If I put 4 in each of those 2 groups, how many did I use? 8. How many are left? 0. Down here I have 8 divided by 2 is? 4. 4 times 2 is? 8. How many are left over? 0. How do I check my work? Multiplication. I'm going to multiply 3,174 times 2. 4 times 2 is 8. 7 times 2 is 14. 2 times 1 is 2, plus 1 more is 3. 2 times 3 is 6. Hey, look, they match. So I know that the answer to 6,348 divided by 2 is 3,174. It's the same thing. It just looks different. All of the steps were the same. All of those steps were the same. They just are recorded a little bit differently. You just write them down a little bit different.
I just realized something.
Yes.
You know how at the bottom of 100, if you go across from the answer, you can also see it.
You can see the 0, 1, 0, 0.
Yeah.
But what I really want you to see is here is that 6, here is that 6. Here is 3, here is 3. Here is 14, there's 14. There's an 8, there's your 8. They're the same thing.
Those are long because I wonder why they call them long division because it's like long for the division.
Yep.
That's how long division is.